March of 1968, the frigid waters of the North Pacific swallowed the Soviet nuclear submarine K-129, taking with it 98 crewmen and military secrets that could alter the balance of the Cold War. Washington knew exactly where the steel giant rested on the ocean floor. What the Americans did not imagine was that recovering those secrets would require the most audacious maritime espionage operation in history, disguised as deep-sea manganese mining. This is the story of how the Americans fished an entire Soviet nuclear submarine from the abyss, using a vessel that cost more than the Apollo space program. 350 miles northwest of Hawaii, the K-129 had become a metal tomb on the Pacific seabed. 16,400 feet below the surface, in depths where pressure would instantly crush a human being, lay a treasure trove of military intelligence. Soviet communication codes, nuclear navigation systems, and most importantly, ballistic missiles with nuclear warheads remained intact within the fractured hull. The CIA had detected the sinking through a secret network of underwater sensors, but recovering anything from that depth defied all known technologies. No American submarine could descend that far. No salvage equipment existed for such a mission. Howard Hughes, the eccentric American billionaire, became the perfect cover for the impossible. His reputation for grandiose and secretive projects provided the ideal camouflage for an operation that would cost over $800 million. The CIA approached Hughes with an audacious proposal to build the world's largest ocean mining vessel, officially to extract manganese nodules from the seabed. In reality, the Hughes Glomar Explorer would be a disguised espionage machine, equipped with revolutionary technology to lift an entire nuclear submarine from the oceanic abyss. Hughes immediately accepted, fascinated by the technical complexity and the absolute secrecy of the mission. Lockheed engineers worked in complete secrecy to design the impossible. The Glomar Explorer needed to be both a convincing mining vessel and an unprecedented submarine recovery platform. 618 feet long, the ship featured a central well 200 feet long that extended through the entire hull. A gigantic mechanical claw, nicknamed Clementine, would be lowered through this well to the ocean floor. Weighing over 2,000 tons, Clementine incorporated advanced hydraulic technology and remote control systems that would allow precise manipulation at extreme depths. Every component was exhaustively tested in simulators that replicated the abyssal conditions of the North Pacific. July of 1974 marked the beginning of Operation Azorian's operational phase. The Hughes Glomar Explorer slowly sailed over the exact coordinates of the K-129. Soviet reconnaissance ships circled at a respectful distance, observing the seemingly routine mining operations. The American crew meticulously maintained the facade, operating real mining equipment on the surface while secretly preparing Clementine's descent. Special steel cables, each capable of supporting millions of pounds of tension, were connected to the gigantic claw. High-precision sonar systems mapped the ocean floor, locating the Soviet submarine's wreckage with surgical accuracy. The most audacious operation of the Cold War was about to begin. 16,400 feet below, Clementine began its descent through the absolute darkness of the abyss. Special cameras, protected against extreme pressure, transmitted ghostly images of the ocean floor. Fine sediments partially covered the hull of the K-129, but the main structure remained surprisingly intact. The mechanical claw slowly approached, its hydraulic arms adjusting to embrace the 300-foot-long submarine. Operators on the surface controlled every movement via fiber optic cables, compensating for ocean currents and the Earth's rotation. After 6 hours of delicate maneuvers, Clementine finally held the K-129 in its steel embrace. The ascent began with extreme tension on the support cables. 3 million pounds of dead weight were slowly lifted through more than 3 miles of water. Engineers constantly monitored the cable tension, adjusting the hoisting speed to prevent catastrophic rupture. For the first 2 hours, everything worked perfectly. The Soviet submarine steadily rose towards the surface, carrying its nuclear secrets towards American hands. Then, at 8,000 feet of depth, sensors detected an anomalous vibration in the main cables. Stress fractures began to appear in Clementine's structure. The CIA's most expensive operation in history was on the verge of total collapse. Critical decisions were made in seconds. Engineers quickly calculated that the cables would not support the full weight to the surface. The only option was to continue hoisting and accept that part of the submarine would be lost. At 10,000 feet of depth, the stern section of the K-129 detached from the claw, plummeting back to the ocean floor. 66 bodies of Soviet sailors disappeared forever into the depths, but the bow section, containing the control room, navigation systems, and 2 nuclear missiles, continued its journey towards the sunlight. Operation Azorian had become a partial success with a devastating human cost. Inside the Glomar Explorer's central well, the recovered section of the K-129 emerged from the waters like a ghost from the deep sea. 100 feet of Soviet submarine, covered in ocean mud and marine organisms, finally rested under artificial light. CIA specialists, wearing full protective suits, immediately began exploring the internal compartments. Nuclear navigation systems remained surprisingly preserved after 6 years submerged. Communication codes, patrol route maps, and operational manuals were carefully removed and catalogued. Each item represented years of strategic advantage over the Soviet Union. 2 R-21 nuclear ballistic missiles, each carrying a 1-megaton warhead, were the operation's most valuable prizes. Nuclear weapons experts carefully disassembled the guidance systems, revealing cutting-edge Soviet technology. Onboard computers, primitive by today's standards but revolutionary for 1968, contained navigation algorithms that allowed for intercontinental precision. The missile's propulsion systems were analyzed component by component, revealing advanced metallurgy and solid fuel techniques that the Americans had not fully mastered. Every discovery was photographed, measured, and sent to specialized laboratories in Washington. Personal documents of the Soviet crewmen provided unexpected insights into military life in the USSR. Letters to families, personal diaries, and photographs revealed not only operational information, but also troop morale and living conditions on board. Training manuals described nuclear launch procedures that differed significantly from American estimates. Communication protocols with Moscow showed command hierarchies and authentication codes that the NSA could exploit to intercept future Soviet transmissions. Every page was a window into the inner workings of the Soviet military machine during the height of the Cold War. Metallurgical analyses of the hull revealed Soviet advancements in steel alloys for nuclear submarines. Samples from the nuclear reactor, though damaged, provided data on uranium enrichment and fuel design that surprised American scientists. Soviet sonar systems incorporated more sophisticated signal processing technology than American intelligence had estimated. Electronic countermeasures equipment suggested submarine electronic warfare capabilities that forced a complete re-evaluation of the American fleet's vulnerabilities. Every analyzed component redefined American understanding of Soviet military capabilities. Moscow remained officially silent about the fate of the K-129, maintaining the fiction that the submarine had been lost in a training accident. Families of the crew received standard notifications of death in service, with no details about location or circumstances. The Soviet Union could not admit that a nuclear submarine carrying ballistic missiles had sunk in international waters, much less that the Americans had recovered critical military secrets. The official silence created a surreal situation where both sides knew the truth, but neither could publicly acknowledge it. Soviet warships intensified patrols in the North Pacific, clearly searching for evidence of the American operation. Nuclear submarines of the Alpha class began appearing in waters near Hawaii with unprecedented frequency. Moscow had deduced that something extraordinary had happened, but lacked concrete evidence to confront Washington. Soviet paranoia about American submarine espionage operations increased dramatically, leading to significant changes in patrol and communication protocols. The underwater Cold War had entered a new phase of intensity. Howard Hughes maintained absolute secrecy about his participation in the operation, taking details to his grave when he died in 1976. The Glomar Explorer continued legitimate mining operations for several years, maintaining its cover even after the secret mission ended. Crew members who participated in the operation signed confidentiality agreements that remained in effect for decades. The CIA developed security protocols based on Operation Azorian that influenced future submarine recovery missions. The operation's success set precedents for cooperation between intelligence agencies and private companies. Technologies developed for Operation Azorian revolutionized civilian ocean exploration. Dynamic positioning systems created to keep the Glomar Explorer stationary over the target were adapted for deep-water oil platforms. Mechanical claws like Clementine evolved into commercial ocean mining equipment. High-strength cables developed to support the submarine's weight found applications in bridge construction and offshore structures. The engineering required to lift 3 million pounds from the ocean floor propelled advancements in materials and hydraulic systems that benefited multiple industries. Intelligence gathered from the K-129 influenced the development of American anti-missile defense systems for decades. The flight characteristics of the R-21 missiles allowed for more precise calibration of early warning radars. The Soviet submarine sonar signatures were incorporated into the American Navy's acoustic identification databases. Recovered communication codes provided keys to decipher intercepted Soviet transmissions in subsequent years. Every fragment of information contributed to an American strategic advantage during a critical period of the Cold War. Families of the Soviet sailors never knew that their loved ones had been recovered and buried with military honors by the Americans. The CIA conducted a respectful ceremony aboard the Glomar Explorer, acknowledging the sacrifice of the enemy crewmen. Identifiable bodies were wrapped in Soviet flags before burial at sea. Photographs of the ceremony remained classified for decades, symbolizing the humanity that persisted even during the most intense ideological conflicts. This gesture of respect dramatically contrasted with the ruthless nature of Cold War espionage. Public revelations about Operation Azorian in 1975 caused significant diplomatic embarrassment. Investigative journalists uncovered connections between Hughes and the CIA, forcing partial admissions about the operation. Moscow finally had evidence to accuse Washington of submarine espionage, but decades of official silence limited response options. American congressmen questioned the costs and legality of the operation, initiating debates about oversight of intelligence activities. The controversy contributed to reforms in congressional oversight of secret operations. Soviet submarines drastically modified operational procedures after the discovery of Operation Azorian. New protocols required the destruction of sensitive materials in case of emergency. Self-destruct systems were installed in compartments containing critical codes and equipment. Patrol routes were altered to avoid waters where recovery operations would be possible. The paranoia about American submarine espionage led to massive investments in countermeasures and detection technologies. The underwater Cold War would never be the same. The total costs of Operation Azorian exceeded $800 million, equivalent to over $4 billion in current values. Each pound of recovered material cost approximately $400,000, making it one of the most expensive intelligence operations in history. Subsequent cost-benefit analyses questioned whether the information obtained justified the massive investment. Critics argued that resources could have been better utilized in other intelligence operations. Proponents maintained that the strategic advantages gained were incalculable during a critical period of the Cold War. Engineers who participated in the operation applied their acquired experience to revolutionary civilian projects. Positioning systems developed for the Glomar Explorer influenced the design of navigation satellites. Remote control techniques in deep waters evolved into modern submarine robotics. Pressure-resistant materials created for Clementine found applications in bridge construction and offshore structures. The engineering required to lift 3 million pounds from the ocean floor propelled advancements in materials and hydraulic systems that benefited multiple industries. Documents declassified decades later revealed the full extent of cooperation between government and private sector. Hughes Aircraft, Lockheed, and dozens of subcontractors knowingly participated in an international espionage operation. Confidentiality agreements protected trade secrets while allowing the sharing of military technology. This public-private partnership model influenced future intelligence operations and weapons development. Operation Azorian set precedents for collaboration that persist to this day. American sailors who participated in the operation carried the weight of the secret for decades. Many developed deep bonds with colleagues who shared a unique and unrepeatable experience. Informal reunions continued years after the operation, creating a brotherhood based on an extraordinary mission. Some struggled with the moral aspects of desecrating a submarine tomb, while others were proud of their contribution to national security. Their stories, finally told after declassification, revealed the human dimension of an operation often viewed only in technical and strategic terms. Sonar technology, developed to locate the K-129, revolutionized marine archaeology. Ocean floor mapping systems created for the operation were adapted to discover historical ships and submerged archaeological sites. Techniques for preserving artifacts in high-pressure environments benefited museums and research institutions. Documentation protocols developed by the CIA set standards for the scientific exploration of wrecks. Operation Azorian inadvertently contributed to advancements in the preservation of underwater cultural heritage. Secure communication systems developed to coordinate the operation influenced the development of the modern Internet. Cryptography protocols created to protect transmissions between the Glomar Explorer and Washington were precursors to current digital security. Redundant communication networks established for the mission demonstrated principles that would later become fundamental to telecommunications infrastructure. The need for real-time global coordination propelled innovations that transcended military applications. Later analyses revealed that Moscow had detected suspicious activity, but misinterpreted the operations. Soviet intelligence focused on the possible installation of espionage equipment on the ocean floor, not on the recovery of wreckage. This incorrect interpretation allowed the operation to continue without direct interference. Declassified Soviet documents showed internal debates about how to respond to suspicious American activities. The unwitting disinformation protected one of the most audacious operations of the Cold War. Scientists who analyzed recovered materials made discoveries that influenced nuclear research for decades. Samples of Soviet reactor fuel revealed enrichment techniques different from American estimates. Hull metal alloys provided insights into advanced Soviet metallurgy. Electronic components showed innovative approaches to miniaturization and radiation resistance. Each analysis contributed to a deeper understanding of Soviet technological capabilities and influenced the development of corresponding American systems. Security protocols established for Operation Azorian became a model for future submarine recovery operations. Decontamination procedures developed to handle radioactive materials influenced responses to civilian nuclear accidents. Techniques for preserving evidence in a marine environment were adapted for forensic investigations. Documentation systems created to catalog discoveries set standards for subsequent intelligence operations. The operation created a procedural manual that guided similar activities for decades. Revelations about the operation's costs and complexity influenced debates about national intelligence priorities. Congressmen questioned whether massive resources justified the information obtained, especially considering only partial success. Effectiveness analyses compared Operation Azorian with other sources of intelligence on Soviet capabilities. Debates about transparency and oversight of secret operations gained momentum after public revelations. The operation became a case study on the balance between national security and democratic accountability. Veterans of Operation Azorian were finally able to share their experiences after partial declassification in recent years. Their memoirs revealed the human aspects of an operation often described only in technical terms. Stories of camaraderie, fear, pride, and moral questioning added a personal dimension to a historical event. Veteran reunions continue to this day, celebrating an extraordinary achievement while honoring the memory of the Soviet sailors. Operation Azorian remains a testament to humanity's ability to achieve the impossible, even in circumstances of global conflict.